Okay, question 7 then. 1 plus x to the power of 7. I want to do the expansion. I only want the first 4 terms. Because it's a high power and because there's a 1 there, I'm just going to use the binomial theorem that's in the formula book for 1 plus x to the power of n, which is 1 plus nx plus n minus 1 over 2 factorial x squared plus n minus 1, n minus 2 over 3 factorial x cubed. And that would be the first 4 terms. So all we want is 1 plus x to the power of 7. So all I need to do is substitute 7 in instead of n. 1 plus 7x plus 7 times 6 over 2 times 1, which is 2, x squared, plus 7 times 6 times 5 over 3 times 2 times 1, x cubed, which is 1 plus 7x plus 6 divided by 2 is 3, so it's 21x squared plus the 3 and the 2 cancel with the 6, 35x cubed. Hence, that means I need to use what I've just found to find 1 plus 1.1 to the power of 7. 1.1 to the power of 7 is 1 plus 0.1 to the power of 7. So it's literally substituting in, instead of x, 0.1. So 1 plus 7, lots of 0.1, plus 21, lots of 0.1 squared, plus 35, lots of 0.1 cubed. That's 1 plus 0.7, plus that's 0.01 times 21 is 0.21, plus 0.001 times 35 is 0.035. That makes, or is approximately anyway, that's why it's an approximation because we haven't got it all, which is approximately 1.945. Okay, next question. Okay, differentiation from first principles. So f of x is equal to 3x squared minus 4x plus 7. F of x plus h is 3 lots of x plus h all squared minus 4 lots of x plus h plus 7. And the gradient dy by dx equals the limit as h tends to 0 of the change in the y values, so f of x plus h minus f of x, divided by the change in the x values, x plus h, take away x. So must keep this written down, equals the limit as h tends to 0. F of x plus h is there, 3x plus h all squared minus 4 of x plus h plus 7. Take away f of x, which is here, 3x squared minus 4x plus 7. So be careful on that bit, that it's take away all of that. So keep it in a bracket or change the sign right at the beginning. X plus h, take away x. Equals the limit as h tends to 0. Expanding out of a bracket, 3x squared plus 3 times 2xh, which is 6xh, plus 3 times h squared, minus 4x minus 4h plus 7. Now take away all of this, take away 3x squared, take away minus 4x is plus 4x, take away 7 over x plus h minus x. So now we cancel going across. So equals the limit as h tends to 0. All of this will cancel with something before it. So the minus 3x squared cancels with that 3x squared, the 4x and the minus 4x, the minus 7 and the plus 7. So I'm left with 6xh plus 3h squared minus 4h all over, and that x cancel out h. Cancelling through by h, I'm left with 6x plus 3h minus 4. So as h tends to 0, well, 3h will tend to 0. So the dy by dx will equal 6x minus 4. Now you can differentiate that yourself to check that you get this answer. I would aim at doing that right at the end, not the beginning, so you don't know what you're aiming for, but just to check. So bring the 2 to the front, 6x minus 4, the 7 would go. It's important you get all of those bits in. Okay, B. I now need to differentiate 5 root x. So we can say y equals 5 root x minus 3 over x cubed. You need to write that in indices. So square root is x to the power of a half, and this is 3x to the power of minus 3. So when I differentiate it, bring the half to the front, it's 5 over 2, x to the power of, take away 1 from the power, minus a half. Bring that minus 3 to the front, so it's plus 9x, reduce the power by 1, it's minus 4. And I would simply leave it like that. If it doesn't ask you to simplify, leave it as it is. So that's question 8. Okay, question 9. Find the equation of the tangent. So the tangent is a straight line. To get the equation of a straight line, you need the gradient and a point. So I need to find the gradient of that, which you find by differentiating. So you get dy by dx, and there's my point. Okay, so part A. If y equals 16 over x, we can write as 16x to the power of minus 1 plus 3x plus 2. dy by dx equals, bring the power to the front, minus 16x to the power of minus 2 plus 3. I need to find the value of that at 418, i.e. when x equals 4. dy by dx equals, now let's write it out how we'd be able to calculate it. That's minus 16 over x squared plus 3. So it's minus 16 over 4 squared plus 3. Minus 16 over 16 plus 3. Minus 1 plus 3 is 2. So we're looking for the gradient, the equation of a line which has a gradient of 2 and a point 418. Substituting in the equation for a straight line, y minus y1 equals mx minus x1. Y minus 18 equals 2x minus 8. And you can write that in various ways. So you can put it all over to the same side, or you could say y equals 2x plus 10. But I'm going to go 2x minus y plus 10 equals 0. That was an x. Part B, find the solutions of the simultaneous equations. So basically, I need to solve simultaneously those two. So I've got y equals, part B, y equals x squared plus 2x plus 4, and y equals 4x plus 7. So all I'm going to do is substitute what I've got for y there into this one. So sub 2 into 1. So 4x plus 7 equals x squared plus 2x plus 4. Quadratic, so let's have it all on the one side equaling 0. So x squared plus 2x minus 4x is minus 2x, plus 4 take away 7 is minus 3 equals 0. So two numbers that multiply to make minus 3 add to make minus 2, and minus 3 and plus 1. So x equals 3, x equals minus 1. Okay, when you're solving this simultaneously, we don't just want the x values, we want the y values as well. So y equals 4 times 3 plus 7, that's 19. And y equals 4 times minus 1 plus 3, y equals not plus 3, it's plus 7, wasn't it? Sorry, I knew I'd gone wrong somewhere. Minus 4 plus 7 is 3. So my coordinates are 3, 19 and minus 1, 3. Well, what does that mean? Well, there's a line, there's a curve. They both go through these 2 points. So it's where that line crosses that curve. So that's our interpretation geometrically, is the fact that the line crosses the curve in 2 places, 319 and minus 1, 3. Okay, stationary points. So stationary points occur a maximum or a minimum when the gradient equals 0. So we've got y equals minus 2x cubed plus 3x squared plus 12x minus 5. We're looking at dy by dx minus 6x squared plus 6x plus 12, and the stationary points occur when dy by dx equals 0. So minus 6x squared plus 6x plus 12 equals 0. Okay, that looks like a hard quadratic to solve for 2 reasons. These are big numbers, and also because I've got a minus in front of the x squared. But they're all multiples of 6, so I can divide by minus 6. So x squared minus x minus 2 equals 0. X minus 2, x plus 1 equals 0. X equals 2, x equals minus 1. So what I know is I've got 2 stationary points occurring when x is 2 and x is minus 1. So let's have a look at the y values. I like to do it in the right order. X is minus 1, so let's substitute that in to find out what the y value is. Minus 1 cubed plus 3 lots of minus 1 squared plus 12 lots of minus 1 minus 5, which gives us minus 12. Save us a little bit of time. And then when x is 2, y equals 2 minus 2 lots of 2 cubed plus 3 lots of 2 squared plus 12 lots of 2 minus 5, and y equals 15. So I've got a stationary point at minus 1 minus 12 and 2, 15. So we need to now find the nature of these stationary points. We can have a look at the second derivative and see what that looks like to help us determine the stationary points. So the second derivative, we differentiate the derivative, which is minus 12x plus 6, substituting in minus 1, Minus 12 lots of minus 1 plus 6 is 18, which is positive. And a positive smiley face means that it's going to be a minimum. That's minus 1 minus 12. And d2y by dx squared, which is minus 12x plus 6, at x equals 2, minus 12 times minus 2 plus 6, minus 24 plus 6 is minus 18. That's less than 0, which is negative. Let's think of a sad face, and that would give us a maximum at 2:15. So there's the two stationary points, a maximum at 2:15 and a minimum at minus 1:12. Number 11. A sheep farmer wishes to construct a rectangular enclosure for his animals. He decides to use a straight wall as one side of the enclosure and fencing for the other 3 sides. The area of the enclosure is 800 square metres. The lengths of the sides of the rectangular enclosure are x and y, as shown in the diagram, and the total length of the fencing is L. We need to show that L is this. Well, from that, there was only really one fact given. The fact that was given was that the area is 800 square metres. So how do we get the area of this shape? We just times the length by the width. So xy equals 800. So we also know that the length of this fencing is y plus x plus y. Y plus x plus y. Well, looking at what I've got here, I don't have any y's in there. So use fact 1 to rearrange and make y the subject of the formula, 800 over x. And then we could sub it into here, sub in. So the length of the enclosure, or the fence, is 800 over x plus 800 over x, which is x plus 800 over x plus 800 over x. Denominators are the same. We just add the numerators, 1,600 over x, as it asks me to show there. Part B says find the minimum value of L, showing that your value you have found is a minimum value. Well, when we want a minimum, or what we did in the question before, maximums and minimums, what do? We differentiate, we put it equal to 0, and we find what value occurs. So although this time we're not thinking of a graph, we're thinking of equation L equals, this could be a graph where that's the y-axis, and then you've got an x-axis. So we differentiate L with respect to x. Can't differentiate it looking like that, so I'm just going to rewrite it a sec. L equals x plus 1,600 x to the minus 1. Differentiating that gives me 1 minus 1,600 x to the power of minus 2. That is 1 minus 1,600 over x squared. Where do we have a maximum or a minimum? It's when the dl by dx equals 0. So 1 minus 1,600 over x squared equals 0. So 1 equals 1,600 over x squared equals 1,600, x equals the square root of 1,600, which is minus 40, or x equals 40. So can I have a length of fence which is minus 40? No, I can't. So it's just going to have to be x equals 0. See if I've got another piece of paper now. So the minimum occurs when x equals 40. Well, they want me to show that it is definitely a minimum, it's not a maximum. So we had dl by dx was 1 minus 1,600 x to the power of minus 2. How do we prove that it's a maximum or minimum? We look at the second derivative. Well, that's one way of working it out. So bring that 0, bring the minus 2 to the front. So it's 3,200 x to the minus 3, which is 3,200 over x cubed. At x equals 40, d2l by dx squared equals 3,200 over 40 cubed. 3,200 over 40 cubed is 1 over 20. But I'm actually not too worried about what value it is. What I'm interested in is that it's positive or negative. That's positive. Positive. Think of your positive smiley face. It's a minimum at x equals 40. Does it ask me for what the y value is? What's the minimum value? I do actually need to know what the minimum value is. So remember, L was x plus 1,600 over x. Putting in 40 is 40 plus 1,600 over 40. L equals 40. Add, that's 40 as well. L equals 80 meters. Okay, I think I'm going to need to break at that point.